They are.
All right. Do we have any new faces here today? No new faces. So,
We
sorry.
will have someone new from Bloomberg today. Gabe, do you want to introduce yourself?
Yeah, hi. My name's Gabe. I work with Aiden and Sambav. Internally, we've been doing a lot of build pack stuff and just happy to be here.
Welcome, Game. Happy to have you. Up next on our agenda, we have release planning and updates. Do we want to start with the implementation team?
We have been having some conversations that we'll be getting to in this meeting that may affect our release schedule. So I'll just.
Lifecycle release planning is stay tuned for 5 minutes from now. Up next, what about platform? Are we expecting any platform releases, pack releases anytime soon?
I know for Tecton, there were some changes that we looked at regarding security context. I think the OpenShift people contributed something in that regard. And so I think we're going to tack on a couple little things to come up with a soon new Tecton version for some of our tasks. Outside of that, for pack, I don't think there's anything scheduled. I did reach out to David, and I think what we're looking to do is maybe see if we could make a request for these sort of updates to happen in Slack as sort of like a reminder, so that way we could present them in this meeting. But I know that David, who's kind of owning pack right now, isn't able to make this meeting. So just kind of wanted to verbalize that as well.
Yeah, that makes sense. Maybe we could even get David to put them directly into the doc in advance or something. Yeah. And then distribution, anything related to distribution? I can take that as a no. So moving on, circling back to our lifecycle release, I think Natalie is going to talk about maybe a strategy around releasing a version of the lifecycle that is a bit more conscientious about the SBOM migration. So we migrated from the old SBOM format to the new SBOM format, but unlike in most of our other migrations, we did not provide a way such that the BOM that used to be available on old platforms is still available on old platforms. So Annalise is going to talk about that a little bit.
Yeah, so there's a spec PR linked in the working group document. I think Emily summarized it pretty well, but basically the platform API and the build pack API are supposed to be able to function somewhat independently. But when we released the new SBOM feature, we created a situation where old platforms that expect to find a BOM in a label can't upgrade their build packs without that BOM just going away. And that could be a problem, right, for some platforms. So we basically, in the situation we're in right now, those platforms will just have to upgrade to the 08 API in order to use newer build packs, which is a pretty difficult migration path. So the solution, we think, and what we kind of wish we had done from the beginning, is to allow build packs to output both BOM formats simultaneously, and then older platforms will still have a BOM in the label, and newer platforms will have both as of the current platform API.
Is that true that the new platforms would have both? I thought we were going with the platform would have whatever the platform's API says it should have.
As of the current platform API, it says it can have both.
Okay.
So I think in the next platform API, I would like to take it a step further and only have the new one. So build packs produce both, but which thing you get as a platform depends on which platform API you're on.
Yeah, that's what I was, I guess, expecting, but it seems like we're putting something in the middle that allows for a smoother transition, if I'm not mistaken.
Yeah.
What could happen if you were in the next platform API, but you have built back with API O2 or something, or like an old build back API that doesn't even know of the new format?
There's
And
no way to get the new format without a build pack that knows about the new format.
no, I'm saying the build pack knows only about the old format. With the new platform, we get rid of the labels. The old build pack still outputs whatever it was outputting since forever, and those things are now vanished because of the new platform API.
Yes.
Okay.
Which I think makes sense. It's like you're not going to upgrade to that platform API until you're ready to change the format you get the bomb in. Like at some point we have to start removing things or we'll never get out of the situation where we're breaking something. But I think the platform API can be a good like opt-in situation there, right?
Well, I guess I want to kind of say like it's not always the build pack author's choice. Like it's not like the Paketo situation where you control the build packs, right? Like if you're on a platform where build pack authors don't work at that company, that's not always like I opted in to this platform being upgraded. The platform decided to upgrade independent of my choice to upgrade, right?
Yes, that's true, right? There's definitely some trade-offs here. I think it still makes sense to me, at least, because I see the bomb as a like platform provided feature. So when you change platform APIs, you're getting a different feature from the platform. And I think we need to get to a place where we can remove it because these large labels are, you know, like taking down Kate's nodes and causing a lot of problems. So I see this as like, I think the direction we went was in the version of like being very strict and making it so there's no path forward with the migration, right? Now we're trying to ease it up a little bit, but I don't think we want to ease it up so much that nobody migrates either.
In terms of the current migration plan, like for example, the way we migrated was update the platform, still while keeping the whole life cycle around. And once you have the new build packs, just update the life cycle that ships with the builder, and that's it. Am I missing something?
Well, right now you're in a situation where you can't upgrade your build packs without breaking old platforms. Like you can't upgrade build packs on old platforms without breaking them.
Can't
And we would like
build packs. But in this case, we couldn't support it, right? Like because the older platforms didn't know about the test form location. So even if we wanted to, we couldn't get the restore behavior.
if we allow build packs a situation where they can supply both formats, then you can still get the old behavior on old platforms and the new behavior on new platforms. You're never going to get the new behavior on old platforms in this case. Like we have tried really hard to keep these APIs orthogonal, but in this case, they're not perfectly decoupled from each other, right? So we can't upgrade things in the exact ways that we have before because there's an interaction here. And I don't think there's any way to totally like undo that interaction. But I do think by allowing build packs a grace period where they can supply both, you can at least get the old behavior on the old platforms.
Can we make it so that they can supply both, but what would be exported would depend on the platform API? So
that's what we're proposing.
Okay, so right now, if they supply the legacy format, but the platform supports the new format, the legacy format would not be added as a label.
In the current platform API, it says it would do both, but I think we'd like to change it such that the platform decides whether it's new or old, but the build pack can supply both, so it can work in both places. Does that make sense?
Yeah, and that's in platform 08, right?
Yeah.
Not in 09. Okay. So we are patching an existing spec.
I think we don't need to patch the spec if we're talking about allowing the build pack to supply both, because nowhere in the spec does it say you can't set extra fields, right? But I think in the next version, we'd like to be more explicit about it and include it as like, you know, in that deprecation section, like here's a way to supply things in the old format. Our proposal is to patch the lifecycle so that we can unbreak people in a way that is compliant with the spec, but maybe not fully described in the spec, and then add more stuff to the spec so that people know what happened.
Add more stuff to the existing spec. or
With
add
the
more
next
stuff to a
version of the
new
spec, we will
release?
explicitly lay out that deprecated behavior.
Why not just release a new version of the lifecycle with that new spec?
Release a new version of the lifecycle with the new spec. Like we can release the new spec and then release a new version of the lifecycle with the new build pack API. That is one way to do it. We're proposing doing it in the other direction because we have actively created a problem where build pack authors are stuck and cannot move forward. And the change we want to make to the lifecycle is not going to break anyone. It will fix people, and it is in compliance with the existing spec. Like, although we'd like to add more details that describe the deprecated behavior, we can make this change without, while still being 100% compliant with what's in the spec right now. If that makes sense. Like the lifecycle has to do everything the spec says the lifecycle has to do. But the lifecycle can do something more if it wants to. And maybe we also want to put that in the spec, and we will. But I think getting a patch out to fix people sooner rather than later is the responsible thing to do here.
I think it would be a little weird if I'm just imagining like how the life cycle code would read. It'd be a little weird if we, you're on build pack 07. Okay, we're just going to fail if you try to output both BOM formats. And then on build pack 08, we'll proceed and process, without complaint. And so I think it effectively, what it would mean is build pack 07 would become an API that nobody uses, which, maybe we're, that
I mean,
maybe
I feel like this happens, right? Like this is the thing that happens. I guess it strikes me a little weird to be like, we are underhandedly, like under the table, basically knowingly doing this thing and basically under specifying. It's like, for sure, lifecycle could add like any functionality that does stuff that's not in the spec, I guess. Like, I don't know, just feels like a weird stance to take.
But yes, sometimes there are API versions of something that nobody uses, right? Because a mistake was made. But I feel like that's never the ideal situation. We don't have to be in that situation. I think it would make more sense to people if the behavior that we say exists and is deprecated in 08 also exists and is deprecated in 07. I think it might be perennially confusing if it's missing in 07 and then is reintroduced deprecated in 08. Like, I don't think I think that's a worse long-term position for us to be in, even if the process did not unfold as perfectly as we like it to.
I mean, is there a concept of just like yanking that version?
I mean, there are already build packs in the world. That would be a bigger break to everybody, right?
We could formally denounce that version when we release the next version, and then document that we're providing a migration strategy from it.
I mean, the API version is not broken. It's perfectly all right, and you can migrate to the newer platform API and then update your build pack API. It's just that it closes off a different migration strategy where you're first updating your build pack API and then updating your platform API.
The problem is right now you have to do it simultaneously. Like, you have to update all your build packs in your platform at the same time, right? To get a bomb.
No, you can update your platform to 08, have your build packs be on 05 or 06. They'll still put out the old format that still gets put on the label. So you updated the platform to 08, it's fine, it's running. Then you slowly update your build packs from 06 to 07. No information is lost in the middle. That's how we did the update. Like, it was painless for us.
I think that works when you're thinking about like a platform, right? But it's more like when, as a build pack author, if you're providing build packs for a variety of platforms, then it's never safe to change your format, right?
I mean, that's the issue with anything, right? Like, unless you've updated your lifecycle or unless you've updated your platform API, how can we introduce new features in build packs API with like expecting it to work in all the past versions of platform API when we have forever frozen that platform API?
But we're removing a feature here, right? Sorry.
Yeah, like, we've actually managed to do that to a large extent. Like, as long as you have the newest life cycle, like, there's no world where you can freeze the life cycle and update other things. The life cycle always has to be out front. But up until this point, like, we've made a lot of breaking changes to the build pack API, but none of them sort of like removed things that were then visible to the end user through the platform. It's been decoupled up until this point. But this is a case where it's not decoupled. Like, changing the format the build pack provides the bomb in changes the format the user gets it in, which makes it like a categorically different type of change than a lot of the other ones we've made.
We had done this change the way we did other changes in the past, we would have taken the data in the SBOM file format, and on older platforms, we would have put that in the label. But that would have definitely created labels that are too large. So that path was like just by definition cut off for us, and that's kind of how we got here.
Yeah, that was the original backwards compatibility clause in the RFC, but we decided not to do that because it would just generate really large labels. So even in this new case, it's not like you're getting the newer format in the older version. You're just outputting both formats and then hoping for the best, like covering all the platforms, so to say.
And then eventually we need to start deprecating APIs, right? Like, it'll be a while before we get to this one, but we need to start removing older APIs so that we can have an end in sight for this compatibility matrix. We cannot support all of our APIs forever.
The only thing that concerns me is that, like, it just introduces a way for like build packs that are using this kind of information to potentially generate large labels. Like, if they want parity between what they're outputting in the legacy BOM format and what they're outputting in the normal file-based format, we sort of reintroduce the problem in a different way. And if we don't do it that way, then it means that the build packs are outputting a smaller subset of the data in the legacy format than they are in the file format, which is a weird decision to make as a build pack also, like which fields do I keep in the legacy format knowing that it'll be too large versus which do I keep in the newer ones because I know that that can just take whatever. I'm strictly speaking as a
The
perspective.
concern doesn't worry me so much, like thinking about my time back as a Java build pack author. It's like, I don't want to break people. That's the only reason that I put things in the old format, but I want to encourage everyone to use the new stuff. So I built out the new format.
You don't have to output both formats.
Yeah, you don't
Right.
have to output both formats. It's only if you care about compatibility on older platforms.
And there's nothing as a platform you can do to completely prevent these labels, even if you're on the newer API.
We are proposing that in the next platform API, we totally remove this label regardless of what the build packs are setting. So like new platform, no label.
What do the build packs experience though? Do they can still write the legacy bomb format?
Yeah,
Have we
build pack
decided
shouldn't
yet?
have to know what kind of platform it's running on. So it will write both. The old stuff will get dropped on the floor in a new
I
platform.
feel like by definition, it being dropped on the floor means the build pack has to care what the platform is doing, right?
Why?
Because it's functionality that's getting removed, right?
From the build pack's perspective, nothing changes though.
Right, the build pack doesn't know what platform you're on, right? I guess that's the idea. As a build pack author, you don't have to.
But presumably I did work to write that bomb, right? And the fact that it just gets dropped on the floor is a thing that if I was a build pack off of that build pack, you're saying I should care, but then not care.
We should
Because I
probably
don't care.
warn, right? Sorry, I mean to cut you off.
Yeah, like
Yeah. So we're proposing it as a deprecation. I think we're proposing if you only set the old format, we'll warn. If you're setting both, we're assuming you're sort of like doing it on purpose, but eventually we'll remove the old one.
I think we could still warn when you provide both and the old one is ignored too, right?
I think then a build pack that's trying to do compatibility will throw ugly warnings on every single build on a new platform forever.
Doesn't have to be an ugly warning.
All the warnings are a little bit ugly. If you see like 7 warnings every time you run a build, I feel like you start to worry that something's wrong.
It could just be note multiple formats, you know, legacy format provided in addition to something using new format.
Yeah, I mean, we can, if people feel really strongly about it, like part of me feels like the warning is very useful if you only have the old one, because clearly you haven't realized that you should be migrating and doing the new thing. But if you're doing both, I feel like it's like, yeah, you're doing the thing that we expected you to do here.
I have one more question. Do we care about the bomb? Do we care about the label? Do we care about the legacy bomb being present somewhere, or do we care about the label being the way it is?
We care about having bomb data in the old format on old platforms. And that means in the label. Like if you move it somewhere else, then you've still broken the old platform that is expecting it to be in the label.
That's what's currently happening. You take an older build pack API, you take an older platform API, it'll still be in the label.
But those platforms, we've told them that they can continue to upgrade their build packs. That's what's different here.
Just time check. I know we're at half on clock. And there's 2 other topics as well.
I think we do want to make a decision on this though. Like, I know there's been a lot of questions, but is anyone like, so opposed to this path forward that they want to put their foot down and say, no, don't enable this migration?
Not opposed. I'm just curious why even upgrade in the first place, right? I think the only thing present, the big feature in the last build pack API was this SBOM stuff, right? Nothing else. As a build pack author, why would you make the jump?
I can speak from the perspective of Paketo, and I feel like it would apply to a lot of other build packs as well. Those build pack authors want to make the jump so they can provide the new stuff on the new platform. The problem is people use their build packs on old platforms and expect the old behavior to work, and they don't want to break all of the people in those platforms, and they also don't want to have to start maintaining 2 versions of all the build packs.
Eventually, the old one will be deprecated, right? And there's an impetus to switch to a standardized format that works with modern tooling.
I want to reiterate the time check. Like, let's either decide if we want to continue talking about this explicitly or move on to the next topic.
I don't want to continue talking about it explicitly, but I think we need to know whether it's okay to move forward with actions after this meeting. So if not, if someone has a stop break problem with it, maybe come talk to me and Natalie after the meeting if we don't want to talk about it anymore here.
I think someone needs to write down what is being proposed here, because it's not entirely clear to me, and I'm basing off what I understand off of what's in the spec PRs. So I don't know. I don't know if that's an RFC or clarification in the spec or what, but let's clarify that. I think that's the next step.
The question, at least in my mind, is do we want a useless and ignored build pack 07 or not? If we say we want to fix build pack 07 in a way that's not in violation of the spec as it's written and just ship a lifecycle patch, that seems like a reasonable course of action. But if we say this spec PR needs to get merged first, and we're basically going to tell people don't use build pack 07 because there won't be a migration path for you, that's the other option.
I'm in favor of the patch.
Definitely support the patch also. We could move this to Slack if we wanted to, get some thumbs up so we can move on.
Cool. All right. Additional exportable layers. Let's do it, Sam.
Just trying to find the RFC. I still have to make a few changes, but I will try to summarize what Stephen, Terrence, and I discussed a while ago on this RFC, and if that makes sense. Okay, the idea is that as a build pack author, you may want to output or you want to create outputs in the final application image in paths that are not /layers or /workspace. The use case being certain pieces of software require them to be in certain paths and they're not relocatable. And these paths are technically rebase safe. You're not doing the whole build pack stack Docker files RFC where you're changing the system level layers and adding new files to folders where there already were files. So you're not making changes to /user/lib or something like that. You're doing these kind of changes in a separate directory, maybe like opt/my_extension/whatever. So these parts do not exist in the base run image and the build image, and you want them to be persisted. A single app directory is not enough, because like it just fixes you to putting everything under /workspace. So the idea would be that a build pack can like choose which of the X workspace directories it wants to output things in. And the way it can do that is by declaring like the kinds of workspaces it's compatible with. Names are subject to change. These are just like placeholders, but the idea is these are like the name of the additional workspace directories. So the default one would just be called the default. But now let's say you want to have an AWS extensions workspace directory or a user config directory and so on. So as a build pack, you're defining, okay, these are the kind of workspaces that I want to write to and export out to. And then on the stack side, or whatever your base build image or run image is, if you're removing the concepts of stacks, you can define what these workspaces map to in terms of actual file locations. So you can say that the AWS extensions workspace maps to like /opt/AWS or something maybe. Your user configure maps to /home/cnb.config and so on in the base build and run images. And if they are not defined, then the lifecycle will just use /workspaces with an additional S at the end and the name of the additional directory. So it will be /workspaces/AWS extensions or so on. The way it would work is the lifecycle will simply take whatever is outputted in these workspaces directory and put it in the final image. I also added a few compatibility clauses on how you could potentially implement this in platforms like Tecton, which have a single volume. So instead of mounting the workspace as a volume, you'll mount workspaces as the default volume, and the lifecycle when it's initially doing when it's before it's dropped privileges, will just create some links between the appropriate workspaces / whatever directory to the directory names that were mapped in the base build and run image, and then output them or export these things out when it's running the exporter task. That's the gist of it. There was some additional questions whether like the build pack should be allowed to have a default value in here, apart from something like workspaces / whatever the name is. And what would happen in case of like multiple build packs declaring the same sort of workspace directory name. So for the first one, I don't have a strong preference, but there were arguments that like if you're an AWS extensions build pack, you know that you want to output something in opt AWS, why would you like output it in /workspaces or whatever? That might break things. So that was one argument for having defaults set by the build packs, which can be overridden by the stack, let's say. And the other one was like in terms of multiple build packs sharing the common workspace directory, we sort of already do that as a contract when we do provides and requires. Like those names are freeform, and you expect build packs that are working with each other to sort of work together happily within the constraints of those provides and requires, like if you have a very generic provides like download, and then some other build pack is expecting when it's requiring download to have a very different effect, you're affecting the whole build process. So that free form loose coupling in terms of names and how different build packs interact with each other is sort of already present. The large question was like the default mappings for these directories to exact file paths. The pros of this is that it allows you to output to things after the build process, as opposed to the current Docker files RFC, where that happens before the build process. So if you want to like decide how to construct the output image after the build packs build is run, you can now do that. All of these changes are rebase safe, so you don't need to worry about like what would happen if like I added some extension and now I'm rebasing the base image. Would I lose some of the mixins or something? Like all the caveats of the rebase parts with the Docker files RFC are gone when you're dealing with just these kind of extensions that are limited to a subfolder and does not interact with the rest of the system folders and directories. So that's what the proposal was. There were a few other extensions to the proposal, which have not yet included in the RFC, which were things like a common problem with build packs right now is when you mount the app directory. The first build pack that decides to wipe the app directory can do that, and then all your subsequent build packs now have no way of reading the original source code or performing some other like build processes on them. So let's say you have a Go build pack and a JavaScript build pack. Your JavaScript build pack is responsible for building the front end, and your Go build pack is responsible for building the back end. The Go build pack, out of like whatever performance or concerns or whatever, just wipes the entire app directory after it's done compiling the assets. And then when your JavaScript build pack tries to take a look at the app directory, it just says, "Whoops, there's nothing there." So even though it passed the detect and it gets to build, it just doesn't know what to do. Now you, as a build pack operator, you have to be very careful about the order in which you keep your build packs, and you have to introduce conventions such as like BP keep ders or something like that to prevent your Go build pack from removing certain directories. So the other part of this RFC was like, if we could mount the app directory, a read-only version of that in a separate volume, that's used for detect and as an input to build, but the build packs output their final artifacts in the normal workspaces / default directory. They can choose to do that. The read-only volume mount will not be exported out to the final image. So build packs have to selectively choose to keep files as opposed to just everything from the mounted volume being kept by default. There were again some controversial opinions on this, but like, what if I want to keep some extra files? Now I need to set an environment variable to tell my build pack to keep all of these extra files in the output image and so on, which could be solved by a project descriptor. You could just say like, just keep all of these files and directories in the output image if we decide to go that route. But yeah, that's what this RFC is about. Extensions not included. The last part was an extension, but curious what others think about this idea.
On the original RFC, what do the build packs see when they, so right now the current working directory is the workspace directory. Now there's going to be multiple workspace directories. Is this a big breaking change where they see a bunch of folders inside of workspaces in the current working directory? Are they moved inside of the new one? And if so, how do they find the other workspace directories?
So the app directory would be still parsed the way it is. They would continue to see that as an app directory. If you're on the newer build pack API that does support this, you'll be parsed an additional environment variable with like workspace, the name, and the like the path to where that is. So similar, like I think we have this recent RFC on removing like command line arguments to the build API and moving them to environment variables. So follow something along that line. We can figure out whether we want to pack all of these additional workspaces into one environment variable that's just like a JSON string, or whether we just want it to be like CNB, like deep CNB workspace name, and then the file location where the build pack should output. And the build pack can expect from its API, like build pack toml file, the list of names that it declared it should get access to, so it can use that to map the environment variables that it needs to read.
I think it'd be good to see that interface in the RFC.
Okay.
Because you know, I think it's pretty impactful in the build pack API. Sorry, go ahead.
Yeah, so you're saying, well, what I expected you to say, but I don't think you did say, was that you could have one environment variable that pointed to the workspaces with an S directory, and then because the directories under that would map to the names that you put in the build pack toml, the build pack would just know how to get to them. Like, I don't think I heard you say that. That sounds like an option, right?
Yeah, that is also an option.
Under that case is up to then lifecycle to then move that to whatever the mapping like that user sets, because the user can map the volume to a different path.
Those workspaces / subdirectories are symlinked to those.
Okay, yeah.
So if you write to that, you automatically write to the other one. But it's just that if you use that workspaces / whatever convention, and like you're writing config files or whatever, like you have to make sure that like let's say you set a path variable or something, and in your one of your software packages expects like /opt /AWS to be in the path. Now instead you have workspaces / AWS extensions in the path instead of /opt /AWS. So that was the only confusing bit. Like if you're setting environment variables based on these workspace directories, you would need the resolved path rather than the workspaces / the extension name path. That's why I didn't propose that. Like that's an option, but it's just gonna introduce the same issues, which is why we have like the same set of directories between the build image and the run image, where like, if we have different sets of images, then like handling environment variables and all becomes a bit weird.
One of your examples. Oh, sorry. Go ahead, Javier.
I was just going to say, I'm definitely in favor of not having to resolve any sort of link to be able to make it useful. So if it could be the absolute path, I think that'd be better.
The symlink part is simply to allow platforms like Tecton to easily implement this. So like they can mount a single volume, but the final environment that's exposed to build packs would be the same, and the final output would be the same. That was the only like reason to have that piece where you mount a single volume called workspaces, and then the lifecycle is responsible for symlinking those out.
What does this look like in your AWS extensions example? Like you have the value of /opt, but there's other stuff potentially already in /opt on the base image. So like, how do you know what's changed? Because in the normal one, like if it's a symlink to an actual directory, like how are you going to know what's been created by the build pack?
What's being created by the build pack?
Like if I created a new binary and put it in like this AWS extensions, that's symlinked to /opt. If there's 100 other files in /opt and I create a new file, how do I know what's changed for lifecycle to export?
So one of the requirements for this is that whatever directories you're using must be empty. So like if you're using the top level opt directory, it has to be empty. If you already have files in there, you probably want a different directory, and like it's up to the stack, the base build and run image authors to make sure that happens. We can also introduce a check when creating the builder to do that, but not every platform has a builder. So that's why I didn't.
Did you consider just having extensions run after the build process? Like, would you be able to get the same value out of that and, reduce complexity, right?
Extensions running after the build process, that would work. And I mean, that definitely seems possible. It's just that those extensions will have to run on the output application image of some sort.
Just time check. We have 9 minutes left. Do you want to keep talking about this, Sam, and punt the kind of run? I know you want Steven around for the runtime, dynamic runtime and selection thing. Are you okay punting that for next week?
Whatever people feel. Preferences?
I feel like I need some time to read the RC. I haven't read it yet. So maybe we do that and then come back to it.
Yep.
Unless I'm the only person that still needs to read it. But
no,
this is great. I was just gonna say, I feel like you're describing problems I kind of knew I had, but like the AWS extension thing is actually something I'm dealing with right now, and just kind of fudging it in the build and run images. So yeah, I really want to figure this out.
Yeah, I know for like, yeah, go ahead, Steven.
Sorry. This still leans a little towards adding a new special thing to me, as opposed to extending. Like when we talked about, I think the last time we talked about this, we talked about, is there a way to make the concept of one app directory a little more generic, right? And can we use that in order to say, well, could opt be an app directory in some, platforms? I think this is better than past proposals in moving towards that. It's a simple API, especially if, like Joe said, we have a workspaces environment variable, and the build packs can find their directory under it, right? Like I like the simplifications. I think it's heading in the right direction there. I still worry it doesn't quite feel like, we had app directory before. This isn't adding complexity. It's just turning that into a more generic concept. I think it's probably possible to get further in that direction with maybe just some name changes and, the ability maybe for other directories to be supplied at build time, just like the app directory is. I think that could maybe help also. I do wonder, because we support rebase safe extensions. I want to talk more about where extensions don't fit the use case, if that makes sense. Not saying that I don't think we should do something like this, just want to understand better where that's not meeting the use case you have here. And similar questions to what Anthony has. I know we said we'd schedule more time to talk about this idea and we didn't do it. So we should do that at some point for sure.
We have 5 minutes. I can just quickly talk about the run image proposal I had. It's more about dividing up the chunk of work that is there to support the whole Docker files RFC. So you originally had 2 RFCs. Steven, one was for the dynamic run image selection and the other one was for Docker files. But we found out that we could just do dynamic run image selection through the Docker files thing using the from instruction. So the last from instruction wins and that becomes your new run image. Now, the whole Docker files RFC is a significant chunk of work to roll out in one API. The idea was that we could build out first in parts of the lifecycle that do simply the orchestration of the extension. So they run the detect, build, etc. for the extensions, and then coordinate passing the provisions and requirements between the build packs and the extensions and so on. But the extensions can only output Docker files with a subset of the Docker file instructions. So you can't use copy, you can't use run. But everything else seems fine to me, like setting environment variables, setting the base image and so on. So like, let's say you set a new run image. So it's not about changing the build image. That's out of the question. It's only about changing the output run image for the app image. So let's say the extensions decide that. So the common use cases, let's say you have a single builder that can run different kinds of build packs. One of those is Go. When you're running the Go build pack, you want the output image to be, the output base image to be a Scratch image. When you're not running Go, when you're running anything else, you want it to be like a proper operating system. Now, in the current case, what you have to do is you have to create a separate Scratch builder, just including those specific languages like Go or native JVM or whatever. And then you include the same build packs in your normal builder. Even though like technically for most people, the Scratch builder is a better option. So now you have two builders, and the user has to be cognizant of the fact that, hey, I'm building a Go application. I should be using the Scratch builder rather than this all-in-one builder that just knows how to build everything and does and makes the right decisions for me. So the idea was like to divide it so that first we can proof out this concept of extensions, give them a limited capability of outputting Docker files with certain instructions. If it finds any non-compliant instructions, the lifecycle simply fails. And that can happen before the build step. It won't be expensive since all it's doing is just like recording some config values for the output app image and then recording the run image argument to be passed to the exporter and the analyzer, I guess.
Like to back up a little bit, you're just proposing, this isn't a new feature you're proposing. This is just an order that we implement extensions in, where we implement all the metadata parts first so people can start using those features. And a big nice thing about the metadata part is the metadata includes which image to base the thing off of. So you could even build the thing ahead of time and use it there. And then later we introduce the rest of the instructions. I think it's a little weird to support a format called Dockerfile without the common Dockerfile instructions, but I'm not opposed to it.
That was what people were worried about the last time we discussed it. Like, you're introducing the Docker files format, but then you're just allowing people to set environment variables and like arguments and base images. But like, if you want to build towards a common API, and if you've settled on Docker files, it seems weird to introduce a new API just to set.
It's not unheard of, right? Like, Dockerfile is not a standardized format. There have been, plenty of the Dockerfile builder type things, like Conoco for a long time, have just not supported large chunks of what Dockerfile can do, right? Yeah. It's not it's a surprisingly unstandardized, it's a common pattern to just kind of treat Dockerfile as a type of way of specifying a file. And so I'm not opposed to it because of that, right? If it were more strictly defined, I'd feel pretty weird about it. But because of the prior art, it doesn't bother me too much. It feels a little weird, but I'm not gonna. Or if somebody put an RFC in front of me, I would probably say yes instead of no.
So that's what the other question we had. Does this need to be an RFC, or does it just need to be like pull your RFC and merge that? And then this is just how the lifecycle team decides to implement it over the course of different build pack and platform APIs. The RFC would be implemented as a whole some point in the future. It's just that in the middle, this is one chunk of work, and then you do the next chunk of work.
I think, wouldn't the spec need to be able to say that it supports certain Dockerfile instructions?
Yep.
So at least at minimum that, right? Maybe not so much hard. I was going to bring up, since we're talking about different things, I know we're at time, but what about labels? Is labels something that would be supported in Docker files already?
I guess anything in the Docker files world that is just modification of the image config should be fine, and anything that's anything that's not using run and copy on build and add is fine.
Cool. I like that. I think I've been missing labels for quite a while, so that'd be great.
I mean, we can set labels in the build packs API, but okay.
Can we do that? I guess I missed that part.
Yeah, we can.
Arbitrary labels?
Yep.
Oh, damn. All right. It's been a while.
I'm not hearing any no's, so maybe we can circle back to this conversation in Slack. But the idea is to just merge the RFC and then split out the spec and lifecycle implementations.
I'm still kind of maybe a little bit orthogonal to this. I'm still hesitant to merge the RFC without more of a resolution on the security posture of the first looking like the first implementation is going to use Buildo with a bunch of holes poked through. So as long as you're okay waiting for a resolution to that, if that makes sense, before the RFC gets merged, then that would be
I think we can include a conditional clause that whatever parts of the RFC are implemented must work for our standard Gates clusters under a normal, under a normal security profile. That at any point when it's implemented, that would cover all of our bases. So this part can be implemented, it'll work on all standard clusters with a normal profile. When you want to implement the next part, it will.
Awesome. And I think maybe some context I missed that Natalie just put in the Slack is that you're also moving forward with the Conoco-based implementation. Okay, so then it's probably not as much of an issue. I'm very glad to hear that.
I think Natalie already has a pull request to do the orchestration bits, or at least it's in draft. So that's why I was thinking like that would be an easy and quick win. It's not something that we have to prove out, like the Conoco build implementations might take a while. And this is just like orchestrating binaries that we've been doing with the build packs API.
Sounds good to me. I could add a note in the RFC that says these parts will be implemented first. If you wanted to make that move faster, you could PR to my RFC. some notes there.
Yeah.
Cool.
I guess what's the pushback on just if we wanted this to move kind of independent work, like just pulling those bits out and just pulling that out of the RFC? I feel like we've done that in the past.
It'd be a pretty confusing RFC to split it onto here's the whole extensions proposal, but then no file system changes, and then here's the extensions proposal with file system changes. Or like if you came back and read the RFC later, it would be pretty unusual. And also I think we're pretty much with the implementation thing resolved. I think I'm ready to approve at least, or I guess it's my RFC. So I'm ready to say people should look at it.
Well, we're quite a bit over time now. Should probably wrap up and come back to this.
Cool. All right.